Today, I want to talk about spacetime. Spacetime is the idea that space and time are connected. Previously, it was thought that space and time were separate. Space was a three-dimensional set of coordinates indicating where you are, and time was a one-dimensional coordinate indicating when you are. One of the key points in space and time being separate is that if you measured space from two different locations, one of which is moving, then you would only need to account for the difference in speed between the two locations to get the same measurements. However, as part of Einstein's relativity, he found that space and time are actually connected, forming one four-dimensional set of coordinates describing both where and when you are. The key feature here is that you cannot change space without also affecting time. So now, if you make measurements at two different speeds, you have to account for both the difference in speed and how time changes. Previously, to measure both space and time, you could draw a large three-dimensional grid to measure space and use one large overarching clock to measure time. Now, with spacetime, you have to use a four-dimensional grid of space and time. However, since four dimensions can't be visualized, at least not by us, we can instead represent spacetime by putting a small clock at each point on a three-dimensional space grid, instead of the one singular clock. This connection between space and time has a few interesting consequences. For one, if two people measure two events from two different reference frames, they may not agree on where or when both events happen. For example, let's say you have two observers watching lightning strikes, one of whom is on a moving train. The observer on the ground may see two bolts of lightning strike each end of the train at the same time. The observer on the train, however, would see the bolt at the front of the train hit first, with the bolt at the back hitting sometime later. Now, each observation is completely correct. It just depends on your reference frame and speed. To the person on the ground, the two strikes were simultaneous, while the strikes actually had a time delay if you were on the train. This phenomenon is known as the relativity of simultaneity. While the connection between space and time was found under special relativity, the truly weird phenomena show up when space-time interacts with matter. According to Einstein's general theory of relativity, matter creates gravity by distorting space-time. Space-time, unaffected by gravity, forms a nice, evenly spaced three-dimensional grid with a bunch of synchronized clocks at each point on the grid. It should be noted that any object moving through spacetime will follow a straight path and move at a constant rate through space. When we introduce gravity to spacetime, spacetime stretches toward the mass. This causes a lengthening of both time and space, so time passes slower in places of high gravity. For the stretching of space, this doesn't necessarily make things longer, but makes space itself longer. So the object moving through space at a constant rate appears to go faster the closer it gets to the mass. Note, this isn't exactly that the object itself is moving faster, but rather that space becomes increasingly more stretched, so for the object to move at the same speed relative to space, it has to appear to be moving faster. This is where the acceleration due to gravity comes from, a literal stretching of space. This stretching also curves spacetime, causing straight lines to form circles near masses. This is the origin of orbits, a curving of spacetime. Spacetime can actually be stretched to such extreme levels that the distortion becomes infinite near the center, preventing even light from escaping the curvature. This forms a singularity, also known as a black hole. Another phenomenon is gravity waves. These occur when a mass distorts space-time very suddenly, so that it causes a ripple effect, like a rock thrown into a pond. These oscillating distortions of space-time then travel outward from the source at the speed of light. Nevertheless, hope you enjoyed it, hope you learned something, and see ya.